Okay, so first things first, where do 1 and 9 go? Okay, so where do 1 and 9 go? Well, since 1 is smaller than all the numbers, 1 has to be to the left and above everything. And similarly with 9, because we're increasing along all the rows and we're also increasing along all the columns. So yeah, the largest and smallest have to be in the corners. And here's this notation that I use for casework, which is 2 times. So if I do something that doubles that, like assumes that we're going down one of 2 equivalent paths, I just do 2 times, and then I remember to multiply by 2 at the end. So here we put the 2 over here, because that's basically the exact same if we put 2 over here. And next we have an actual decision to make. Do we put the 3 here or do we put the 3 here? And so we make a break in the tree. So we have this and this. So we can either put 3 here or we can put 3 here. And then now I'm going to look at this case first. In this case, we can put 8 here or here, but they're the exact same case. So I'll just put it here and then I'll double this value. So it's 4 times. Over here, you can, well, firstly, you can figure out that 4 has to be here because all of this is ascending, and this is ascending. So therefore 4 has to be less than all of these numbers, or this number has to be less than all of these numbers, which means that the smallest remaining number has to go here. So then we have 4. And then now we're left to place 8. We can place 8 here or here, and we'll split up this case. So we duplicate it, and case 1, we put 8 here, case 2, we put an 8 over here. And then so in this case, we can put these 3 values are going to be 5, 6, and 7. But, well, firstly, we know that 7 has to be here because it's larger than, we're given that this square is larger than both of these. So that means that the largest remaining one has to go here. So that's a 7. And swapping 6 and 5 doesn't make a difference. So that means the value of this thing is 2. So the value of this entire case is 4. So there's 4 cases that are like that. And we just need to resolve everything else as well. And so, for example, for this one, we can choose one of the 4 remaining numbers to go here. So we have 4 choices to put one there. And over here, this value will be fixed. And then after that, these 2 can swap. So there's 2, so there's a total of 8. And so 8 times 4, so there's 32 different values there's 32 different grids in this case. And then in this case, we can choose any of the numbers to go here. So that's 3 ways, and then these 2 will be ordered. And so there's just 3 ways to finish this. So there's 6 in this case, and we add up 4, 6, and 32 to get 42 different ways.